So, can you please introduce yourself?
Yes, sir. Yeah. My name is Mohammad Ali, sir, and I'm currently studying engineering final year in RGKT campus and in the stream of computer science and engineering. Uh, and I have pursued GATE and got 203 All India rank in CS discipline, and also attempted BARC exam and got selected for interview. So I'm here to attempt an interview. Yeah, that is.
Okay. Uh, so, Mr. Ali, are you aware what kind of research happens in BARC?
Uh, no, sir. I'm based. It's no. I'm currently not known about BARC, but I have an idea that it happens based on atomic energy, and
So,
in stream
what
of
computer
CS.
science students will do? Yeah. So, what computer science students will do over there if it is based on atomic energy?
Yeah, CS display students are not directly directly works in related works of atomic energy, but they indirectly, however, may process in different forms indirectly to the atomic energy by some core subjects like CN. Those are helpful in such streams.
Okay. For interview, can you list down some 4 5 courses where you are comfortable of your
Yes, sir.
computer science domain itself?
Yeah, okay, sir. I'm proficient in data structures, computer networks, uh, theory of computation, and also in operating systems and computer organization architecture.
Okay. Fine. So, Aditya sir will start with the data structure first. Sir.
Sure. So, thank you, sir.
Yeah, okay, sir.
So, hi, Mohammad Ali. How are you? All good?
Thank you. Yeah, I'm good, sir.
Awesome. Welcome. So, first of all, if you don't mind, I would like to ask you a few questions about your resume before we proceed to the technical questions. Are you fine with it?
Yeah, I'm fine.
Awesome. So, as I can see that you have given GATE 2 times, right?
Yeah,
Once in
yes, sir.
2025 with All India rank 298,
290.
and
Yes, sir.
second time in 2026 with 203, both in CS, right?
Yes, sir.
Awesome. That's a very great achievement, by the way.
Thank you, sir.
Awesome. So, what was your agenda, or what was your target when you attempted GATE in third year
Yeah,
and secured such a great rank?
basically,
Like after your rank, not before your rank. After your rank, what was your target?
uh, no, sir. Basically, I don't know about GATE in much in E2 second year of engineering, second year of my engineering, but I know from some students that some students were focusing on GATE and also higher education, and also some were on placements. I don't know about much about GATE, but once I known about its benefits, I can do MTech in prestigious IITs and also many better colleges. I focused on GATE in second year of engineering, and then there I started GATE preparation. And I don't know about how after GATE good rank. I don't know what to do. Some told me about join PSUs and or join MTech. So I don't have clarity
Mm-hmm.
about that. But E4 with some guidance and extra knowledge from my friends, I know that I need to do better in MTech in better IIT, and my agenda is to uh, perform better in MTech in IIT. I'm planning to join IIT Madras, so in CS discipline, and to
Okay.
score better.
Hmm.
Yes, sir.
So, see, one thing, just to tell you that this is a BARC interview, right? So, this is a
Yes, sir.
BARC mock interview. So, like, you need to talk in context of BARC. So like you have also appeared for the BARC exam, right? So
Yes, sir.
then if you're planning to go for MTech from IIT Madras, then why BARC? Why BARC should actually consider you as a valid candidate?
Yeah, I'm generally I'm not focused well on MTech only, sir. But in my point of view, I'm planning BARC because after myself, I need to I focus on higher education, sir. Firstly, I focus on MTech. So in BARC, while in this program OCS and DGFS, it can provide independently 2 year MTech if I selected
Mm-hmm.
in DGFS program. So I need to
Mm-hmm.
focus on BARC. That's and also it can provide stipend also.
Mm-hmm.
And also I'm interested in some related atomic energy work by some movies and etc. So I need to
Got it.
plan to joining BARC and also pursue MTech in IIT Madras by selecting DGFS program.
Got it. So you plan to do both in parallel.
Yes, sir.
Okay. Got it. So you mentioned data structures, right? So can I assume
Yes, sir.
that when you said data structures, you are also fine with algorithms, both like combination?
Yes, sir. Okay, sir.
Okay, got it. Awesome. So which are your favorite data structures, to name a few?
My favorite data structures are linked list stack, trees also, sir. Trees, graphs. Okay. I'm also
Trees,
proficient in
graphs.
many of these.
Got it. So can you help me understand the basic difference between the various graph traversal techniques like DFS, BFS?
Yeah, okay, sir. Mainly graph traversal is DFS and BFS.
Mm-hmm.
DFS is the depth first search and BFS is breadth first search. DFS focuses on how we can visit neighbor by neighbor by depth wise,
Mm-hmm.
not by breadth wise. In BFS,
Mm-hmm.
we visit neighbors. We visit all neighbors once, and then we visit their neighbors on one by one. In this BFS, we visit nodes of the graph in a level by manner. But in DFS, we
Mm.
go on one node after another by depth manner, in depth. So the difference is
Got it.
that if a node is visited in BFS, then its all neighboring nodes will be visited in next level. But in DFS,
Mm-hmm.
if a node is visited, then only one of its node will be visited in next level, and
Mm-hmm.
after that node, another node will be visited.
Got it.
Yes,
Uh,
sir.
which data structures are used internally to perform DFS and BFS?
Yeah, in DFS we use stack, sir, and in
Mm-hmm.
BFS we use queue so that we can parallelly uh, visit all connected nodes to the current node by
Mm-hmm.
queue. In DFS we use stack so that we can push a node, and then after another incoming node, and after we can
Mm-hmm.
visit that, and after we push another internal node. That way we can push one by node, one or two one node into the stack, and then we visit it into
Mm-hmm.
depth search wise in DFS.
Got it. So, on what principle stack and queue works like respectively, and in a very
Yes, sir.
few sentence, if you can tell, what is the principle on which both the data structures work?
Yes, sir. Stacks works on first in last out principle, where
Mm-hmm.
if a node is visited first, like a 1 2 3 4 manner,
Mm-hmm.
then first node that comes out will be 4 3 2 1. It
Mm-hmm.
works on the principle like first in last out manner, while queue works
Mm-hmm.
on first in first out manner. That if we inserts in a manner like 1 2 3 4, it
Mm-hmm.
comes out like 1 2 3 4 only.
Got it.
That's
So, if I give you a very specialized case of BFS, okay? So, BFS, as
yes,
you
sir.
said, uses queue, right?
Yes, sir.
And queue follows first in, first out, correct?
First in
So,
first out.
let's say we are performing BFS, like the idea is BFS, but instead of FIFO queue, we'll use LIFO queue. There's a hypothetical queue which is
Yes, sir.
following the LIFO order.
Okay, sir.
So, will it behave same as DFS then? If yes, why yes? If no, why no?
If we use queue in a LIFO manner,
Yeah.
yes, sir.
If we perform DFS in a LIFO manner, BFS,
DFS in a
okay,
LIFO.
breadth first
Okay.
search, yeah.
Oh, sir.
But instead of
Okay, sir.
FIFO queue, we are using LIFO queue, last in first out principle. Yeah.
Yes, sir. In that manner, also BFS works as fine as BFS, sir.
Like fine means, can you elaborate on that? Same, not same, special case?
Special case like if an in LIFO manner if we inserted first if there is a node, sir, it has a 4
Mm-hmm.
childrens. Like
Mm-hmm.
if I'm taking an example, if a node and it has 4 childrens, and then if a
Mm-hmm.
node is inserted in queue
Mm-hmm.
by LIFO manner,
Mm-hmm.
if then these 4 children will be inserted, parent then 4
Mm-hmm.
children. If I use LIFO manner, then the four children will come out. After then
Mm-hmm.
parent will come out, like that, in that manner. BFS not works like as it is as BFS if there are more than 2 children,
Mm-hmm.
because
Got it.
if a node if 2 children are inserted one by one,
Mm-hmm.
then if one children is comes out, then
Mm-hmm.
that one children will be inserted.
Mm-hmm. Correct.
That's why it's not works exactly as BFS, but not also as DFS, but it works as something else.
Got it. Okay. So can I ask one more question, or would you like to ask?
Continue, sir. Please continue.
Okay. Awesome. You mentioned that your other data structures that you're interested in is linked list as well, right?
Yes, sir.
Got it. So let's say I give you a linked list with where you are having the head pointer and the tail pointer both. Okay.
Yes, sir.
And it's sorted in ascending order.
Yes, sir.
So what would be the best case complexity to find a particular element within it?
It will be order of n, sir.
It will be order of n.
Yes, sir.
Okay. So why not? We can perform binary search.
We have only one node head is there, sir. So we cannot find binary search by head and last node. We need to search all elements in that manner also. So we take time order of n, linear time.
Okay, but do you agree that if the input is sorted, then binary search is efficient than linear search?
Yes, sir. Binary search is efficient, but here we are using linked list. So
Mm-hmm.
we have only head pointer, and we need head pointer to traverse to other nodes of the linked list. So if we need to search through the linked list, if it is sorted and unsorted, that doesn't matter. We need to go through all nodes.
Okay.
So it takes
So
order of n time.
still the best case complexity would be order of n. Sorry,
Yes,
the worst case you are saying.
Worst case
Okay.
complexity will be order of n.
Best case?
Best case will be order of 1, sir. If the first node is the our wanted node, then it will be order of 1.
Got it. So are you comfortable with the searching techniques, linear search, binary search?
Yes, sir.
Okay. So if we have linear search, why do we need binary search?
If I take an example, sir, if we have 30 nodes, for example, if you have 30 nodes, and if you're performing linear search on every node, suppose if I need to find a node which is last node, if I perform linear search from first node, it will take 30 steps. If I need 29th node, then it takes 29th node. So the average case will be order of n by 2. So the average steps will be n by 2. That is 30 by 2, 15 average steps. But if we take binary search like that, if the data is sorted 1 to 30 like that, then if we perform binary search, then it will be decreased to log n time. Here we can decrease the average time complexity for the searching technique. So we use binary.
Can you do a basic comparison between the best and the worst case complexities for linear search and binary search?
Yes, sir. If the best, in both cases, the best and worst cases will be order of n, sir. Such like if in linear search, if we have if the target node will be the first node, then itself it will give order of 1 time in linear search.
That's
But in
best
binary
case.
search, yes, sir, that's best case in linear search. If in binary search, the target node will be middle node of the sorted list, then it gives the best case of order of 1.
True. Okay. And what about worst case for both?
If for worst case in linear search, it will be order of n, sir. If the target node will be last node in the list, then it gives order of n time. But in binary search, if the if the target node is first node or last node, then it gives order of login time for in binary search, sir.
Okay, so the worst case is login, right, for binary search.
Yes, login, sir.
So if the worst case of binary search is way better than linear search, then why do we need linear search then?
In some
Because the
cases
best case,
yes, sir.
because
In
the best
such
case is same as linear search, and the worst case is better than linear search. So why do we need linear search?
we need linear search in some cases, like where we cannot have sorted list, and also where we cannot change. That means where we cannot jump into between two nodes like that, sir. If we use if we have tree, sir, suppose we have tree, and if we have tree like in left skewed tree, left skewed BST, if we assume that left skewed BFT, there are nodes sorted in decreasing order, left skewed, then it is already sorted, but we cannot use linear binary search there to jump onto different nodes. There we use a linear search in decreasing manner. So in such cases we use linear search. For binary search is better, but we cannot use everywhere binary search. Some cases there where we cannot use binary search, but instead we use linear search.
Got it. Okay. Sir, over to you. Then we can continue. But yeah, first you can ask.
Yeah. You were talking about linked list, right? So
Yes.
just imagine you have 3 pointers of a linked list. First pointer, head pointer, which is pointing to the first node. Then we have last pointer, which is pointing to the last node. Then we have second last pointer, which is pointing to the second last node of the linked list.
Linked list. Okay, sir.
Okay, now we will have to maintain all 3 pointers while insertion, deletion, everything.
Okay, sir.
If I want to delete the very last node,
Okay, sir.
if I want to delete the very last node, what will be the worst case complexity in that case?
The worst case complexity will be order of n, sir.
Okay, why?
Because if we need to delete a last node, we need to update the second last node when we deleted the last node. Yes, sir. If we have 1, 2, 3, 4, 5, like 5 nodes, if the last node is 5 and the second last node is 4, if we delete last node 5, we need to update second last node to 4, second last node to 3, and the last node to 4.
Yeah.
We have a second last node 4, then we update directly it is as last node, but we did not have second last node 3.
Okay.